Hello, this is Ms. DB, and in this video we are going to learn how to do some of the problems on the Chapter 5, Section 4 worksheet, which is on the triangle mid-segment theorem. So at the beginning here we have an explanation about the mid-segment of a triangle, which joins the midpoints of two sides of the triangles. So if you first make the midpoint of a triangle and then connect the midpoints, you'll get a mid-segment. If you connect all of the mid-segments, there's 3 of them in each triangle, then you get this little mid-segment triangle. So your first task on this worksheet is actually to make a triangle, which is easy enough to do. Draw 3 straight lines, use a straight edge to create your triangle, cut it out. Then fold the triangle so that you can create the midpoint easily. That's the easiest way to find the midpoint. You could use a compass too and construct the bisector, but just fold it and then mark where that fold mark is. So that's your midpoint of one side. Then do the same thing for the other side and then the third side. So you have 3 midpoints, dots on your triangle. Now use your straight edge again and connect those 3 to create this mid-segment triangle, which will be in the center of your triangle. Then what I want you to do is cut out the mid-segment triangle, so cut on these lines. Now you'll have 1, 2, 3, 4 triangles. Rotate them, move them around so that their corresponding parts are aligned in the same order, and stack them on top of each other. So what do you notice? You should find something is true if you did this carefully. There should be a lot of congruent parts there. So you can either explain the results, what you got, or you can just take a picture of your triangle showing what is true about those triangles. All right, so then the next part is down here. We're going to look a little bit more about why what you found in your little experiment is true. So here we have the mid-segment KL has been created here, and the coordinates of K and L are the midpoints of HG and of HJ. So they show here how to find the midpoints. You just add the x values of the 2 endpoints and divide by 2, and then add the y values of your endpoints and divide by 2. That gives you the midpoint. And they wrote that there. And then they found the slope of KL. So the slope of KL is going to be exactly the same as the slope of GJ. So it's parallel to the side that it is not touching. So these two sides will be parallel, meaning they have the exact same slope. And then we use the distance formula to find the length of KL and the length of GJ. And when you find those lengths, you're going to find that one of them is half as big as the other one. So 2 square root of 5 is what KL was, and 4 square root of 5 is what GJ was, which shows that the mid-segment is half as long as the side opposite. So you're going to do that for this problem here. Number 2 and 3 go with this figure up here. So first you're going to find the slope of AB, which is the mid-segment, and of the side right here, ST. And if you find that the slopes are the same, then you'll say that they're parallel lines. If the slopes are not the same, you should probably check your work. I put the slope formula on here, so you can use that, or you can use a slope triangle since they are drawn. You could count the rise over the run. Then you're going to use the distance formula to find AB and ST. It's best to simplify your square root rather than change it to a decimal, but if you can't remember how to do that, it's okay to do the decimal version in this one. And then you'll compare and see if one of them is half as long as the other one. That's what you should find. Here's the mid-segment theorem that says that DE will be parallel to one side of the triangle, and its length is half of that side. So that's what you should have discovered in this problem up here, and now that's a theorem that says it will be true. We can use that theorem to find measures of triangles, because if you know what AC is, then you know that DE will be half of it. If you know what DE is, then you know AC will be twice as long as it. And you might have found that when you did the experiment at the beginning where you cut out those 4 triangles, that that your little triangle was half, one side was half as long as the side of the whole triangle. All right, so here's a problem here, number 5 through 8. We have this figure here, and there's some parts given and some parts that you have to find. So you're going to go through, and these are mid-segments, and we know that WV is a mid-segment because GW is marked congruent to WH. They both have 2 dash marks on them. That means that W has to be the midpoint. And V also is the midpoint because GV is marked exactly the same as JV. They're congruent, so therefore V is the midpoint. And the same with X. So we know these are mid-segments. Then you need to use the fact that the mid-segment, for example WV, will be half as long as HJ. So we know WV is 27, so we can find WJ because it'll be twice as long as WV. Also, WV is exactly the same. Let me use my pen tool here. This WV will be exactly the same length as HX or XJ. That will also be 3 dash marks because these have 3 dash marks. Let's see what else we know. We know that HG is parallel to VX. And how do we know that that's parallel? We know that's parallel because VX is a mid-segment and it is parallel to a side of the triangle, and it's parallel to this side. That means that we have corresponding angles. So if you have 2 parallel lines cut by a transversal, think about HJ as being the transversal, it creates corresponding angles which are congruent. So the 2 angles that I just marked with 1 angle mark will be congruent to each other because they're corresponding angles. And this angle over here, if we mark that these 2 lines are parallel, because this is also a mid-segment, that will also be equal to 92 degrees. So these 3 angles are all the same. So you'll be able to, I think, go through and answer these questions. There's some think to help you guide you towards what the answer might be. So number 9, 10, 11, 12 go with this figure. So let's look at what we have. They want us to find side ST. Here's side ST right here. That's the whole side of the triangle. I know that it is made up of SE plus ET. So if I could find the length of one of those sides, I could just double it to find ST. So let's see. We know that DC is a mid-segment because D is a midpoint of SR and C is the midpoint of RT. So this side here is going to be half as long as ST. In other words, ST will be twice as long as the length from D to C. And I know the length from D to C, it's 36. So ST is going to be 2 times 36. 36, this DC, is going to be congruent to ET or SE, both of those. So 2 times 36 is the answer for number 9. In number 10, we are looking for DE. Okay, the length, that means the length of DE. Here's DE right here. And DE is the mid-segment, which will be half as long as RT. So DE is going to be half as long as RT. And RT, we know that length is 44. So if we just take half of 44, we'll have the answer for DE. And then number 11 asks for the measure of angle DES. Now you have to pick the right angle for that. DES, that's named with 3 letters, start at D, go to E, and then go to S. So I went from here to here. This is the angle they want us to find. So you need to know which angle they're asking you to find. So I'm going to erase some of this stuff. I just want to know, what is this angle measure? That angle, let's look at what we have here. We have a parallel lines, set of parallel lines here and here. Those are parallel lines. They're cut by this transversal from here to here, S to T. That's the transversal. That creates 2 corresponding angles here and here, but I don't know those measures. What else can we use? Oh, I know what we can use, because that didn't help me It's true what I wrote, but it didn't help me because I don't know this measure over here. So instead, let me erase some of the stuff so you can see what we got going here. Instead, I'm going to say, okay, this is the angle I'm looking for. I have a line here that's also parallel to this line because this DC is the midsegment. So I have two parallel lines there. They're cut by this transversal, and I have alternate interior angles. So if you think back to the chapter 3, I believe, where we worked on a pair of angles that are alternate interior angles, it might have been chapter 1. Alternate interior angles, if you have parallel lines cut by transversal, alternate interior angles are congruent. So you need to just look at what this angle is, and then you know the measure of angle DES. All right, finally, measure of angle RCD. So find that angle. Here's R, here's C, here's D. That means they're looking for this angle. So let's see what we can use. We have parallel lines here. Yep, that'll work. Okay, so we have a line here and a line here. They're parallel lines. They are cut by this transversal right here. So again, we can use alternate interior angles using this angle and this angle are going to be congruent. So angle RCD is congruent to angle, is that a F under here? EDC. Angle EDC and angle RCD will be congruent to each other, so their measures will be equal. All right, so hopefully that helps you out and you can answer all of those questions. There's one more to do that has a figure and you're going to do something similar. There's a little bit more work to find in here and no parts are marked congruent yet. So let's go through and mark some parts that are congruent. We know that, let's see, we know that I'll say that G, H, and I are midpoints. That should be given to you. And that means then lots of things. It means that EH is congruent to FH. It means that FI is congruent to ID. And it means that EG is congruent to GD. So that means, and my marks are erasing, but I'll put them back. That means that we have this midsegment from H to I, and H to G is also a midsegment. So the midsegment is half as long as this side, so we can find FD. This piece here will be the same length as these two pieces. And let's see, this here will be the same as this and this. So that should be enough to get you started. And then remember that when you have parallel lines cut by a transversal, that creates some congruent angles. So look for things that will be congruent to 58 if you need to find an angle measure. And then there's a problem, an application problem here, where you're asked to find the perimeter. They give you the lengths, the distances of the outside parts of the triangle. And then they ask you to find the perimeter of that. And then knowing that this will be half as long as this, you can find this length, and this length, and then you can find the perimeter of the midsegment triangle. They'll each be half of these. And then compare the two and see if there's a relationship of the perimeter of the original triangle and its midsegment triangle. All right, thanks a lot. Have a wonderful day. Let me know if you have any questions.